In this session, we're going to be drawing the staircases for the project. We're going to also go through all the details and the points that we need to know about that. So once again, I'm going to open the main plan. And I'm going to also close these extra tabs I don't need anymore to make this bar less crowded and to avoid confusion. We're going to close this one as well, and also this one. We're not going to be needing this one either, and there we go. So we're going to go over to the ground floor, and as you can see here, we've got one staircase or stair box, and we've got another one down here. We're not going to be focusing on the outdoor stairs for now. We will get to those when we get to the outdoor sessions. But what we're going to do in this session is to model the staircases inside the building. So far we know that there's two. Now based on what we can see for this staircase here, the number of the steps for both ramps are the same. How many steps do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 more on this side. So overall we're going to be needing 20 steps. They go up from here to the upper level. Now let's go over to Revit and first get into one of the elevations of this project. And in the first step of the way, I'm going to measure the distance between the ground floor up to the first floor. As you can see here, the offset of the first level is 7 meters, and the ground floor is obviously 0. So basically the distance between the ground floor and the first floor is 7 meters high. Now judging by these numbers, we can already tell that 20 steps of stairs won't be enough to cover 7 meters of elevation. Let's try and calculate it together. For example, if we divide 7 meters by 20 steps, then we would need to have each step to be 35 centimeters high. But that doesn't really make sense. So 2 20-step ramps won't be enough for this. But based on what you see here in the AutoCAD file, we will find this arrow that is similar to double ramp staircases. Because for instance, if there were to be more ramps, then this arrow would have been longer up to here. Basically, it would have turned. But again, that really comes back to the fact that these plans are of the phase 1 type. So for parts like this, you'll just have to figure it out. In the drawing, we have 2 ramps. That's what we can recognize by the shape. So now I'm going to head back over to the plans sheet that I'm going to look for and find the stairs details. So if we zoom in over on this part of the sheet, we will see the building's interior stairs. You can also see in the title it says that this is the interior stairs details. So we can tell a lot of things by taking a look at this view. But first, let's go take a look at its corresponding plan. And by observing it, again, we can understand that there's a contradiction between this one and the architectural plan. It appears that here we have this stair nosing, but if we could take a look at the phase 1 plan, we can see that this stair nosing doesn't exist in the drawing. So this is where we realize that we need to also include a stair nosing, and we also make sure that we report this to the client. We will need to ask whether the stair nosing needs to be included or not, or if its size differs, and just basically how it should be. We were actually told to include this 20 centimeter stair nosing for the project, with a wall in the middle here, and the railings that will spiral around the wall along with the stairs. Now if we take a look at the profile, we can see not only the number of the steps, but also the height of each step. So like if I try to measure the distance for one of them, you see I'm going to measure from this point all the way here, and then I'll see that the height of each step is going to be 17 centimeters and a half. Alright, so 17 and a half is the height of each step, and basically this is how you can specifically figure out the height of each step of your stairs, as the staircase that we've got over here is the same thing repeated over and over. So when it's one profile and it also says the details of the interior stairs, this way we realize that the dimensions mentioned here will be applied to all the other staircases, including the fire escape as well. So far we know that the height of each step is 17 and a half. Let's also check how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the same amount we saw in the main plan. You can also see here we've got 10 and 10 other steps on here. And the height of each step is 17 and a half. Now what's the overall elevation of the entire level? That's 7 meters. Okay, now the height of each step was 17 and a half. So if I divide that by 17 and a half, then I will get 40, which means that we would need 40 steps of stairs to get to the first level from the ground floor. So by doing these calculations, we figure that the stairs of this area are going to have to be 4 flights, as in one flight of 10 steps in here, then going up, Then going higher from this side, there's going to be another flight and another flight over here. So we're going to be needing 4 ramps to lead from the ground floor up to the first level. And then later when we get to the other levels, the elevation will decrease. And we might even end up with 2 ramps of stairs per level. But as for this one, we're going to be needing 4 ramps. Not just for that area, but also for this one. Because the details of both are all the same. And that goes for all the other interior stairs. Now let's go over to Revit and draw those. First I'm going to go over here and go into the ground floor plan. First I'm going to measure the height of the surface of each step, which appears to be 30. To make sure there's no mistake, we're going to double check in here as well and see that this one also says 30. What about the width of each step? If we take a look at the same plan, we will see that the width of each step from the stairwell to the wall here is 130. So that's 130 centimeters. And now we know that 130 is the width of each step and 30 is the height of the surface. So let's keep those dimensions in mind and draw them here. I'm going to go to the Architecture tab, then grab the Stair tool, and I'm going to select the Cast in Place type, then duplicate it, and then I'm going to name this new type Cameo. I'm going to have to turn off the caps lock, and also add stairs. Then click OK. Alright, and for now we're not going to be editing any of the type settings, but I'll set this one to 1 meter and 30 centimeters. We said we were going to be needing 40 steps, and the stairs will start at the ground floor, FFL ground, and it goes all the way up to the FFL of the upper level. That'll be again 40 steps. And now here we can see the riser height is 17 centimeters and a half, just like we said. Then I'm going to set this one to 30. And then I'm going to set this one to left. And finally begin drawing. These stairs are going to go from here, then going upwards by 10 steps. And we're going to go to the opposite side, then draw downwards. Their stairs are going to actually go up to here. Now if I measure the distances to double check, from here to here we will get 30. Now why do you think that happens? Even though we drew the stairs properly and also used the right dimension values. So what went wrong here? You see, over in the detail file, the 130 centimeter value that it shows starts from the structural wall. Okay, so that goes for both sides. And in order to get the actual width of each step, then you will have to measure the distance from this wall all the way to the stairwell. So for example, I'm going to measure, let's zoom in on here, start from this point and go all the way to the wall. Now we got 250. Alright, so this 250 here is actually because of the scale level of this plan. And if we measure from here to here, which is the height of the stairwell, we get 40, whereas the plan says 20. So this one's going to also have to be divided by 2, which means that you'll have to divide 250 by 2 and you'll get 125. So the width of these steps is 125 centimeters. Now this one is the finishing wall. If we measure from here to here, we get 10, which divided by 2 is 5. So there's 5 centimeters of finishing and 25 for these steps width. That's up to the stairwell. So I'm going to go back in here to Revit and see I've drawn the stairs to here. Now if I measure this distance, I'll get 5 centimeters, which is correct. And now I'll just have to change the width of these steps and make it 125. But if I change this to 125, then the stairwell will become bigger. So instead of getting reduced and smaller, and for instance, instead of being 20, it'll become 40. Alright, so there's going to be another issue here that needs to be reported to the client. Now when we actually reported this, they insisted that the stairwell be 20 centimeters no matter what. So then we had to adapt the width of the stairs to that value. So if we need a 20 centimeter stairwell, we would need to make the width of the runs 135 instead of 130. And as for this part where the width of the tread is 3 meters, then I'll have to consider 1 meter and 35 centimeters of width for the stairs. So I'll change this to 135, and I'm going to change the run width of this one to 135 as well. Okay, so this is how they're going to look. And now if we measure the distance of the stairwell, we'll get 20 centimeters, with the run's width being 135. Now I'm going to continue drawing the other ramps the same way. First I'll set the actual run width to 135 and start drawing. So again, we've got another 10 steps on this side, and 10 more on the opposite side. And up to here, we've drawn the steps we needed, but the problem is that the landings are incorrect. Okay, so the landing's gonna have to go up to here, so we're gonna fix it. And let's also check this one down here, expand it a little bit, and then we click finish. Alright, so this is what it's gonna look like. Now let's go take a look at them in 3D. We're gonna pull this box inwards, and here they are. Now for the railing, we're going to discuss those later as to how can we make them exactly similar to what we had in the detail. But so far now we've got all the flights of stairs we needed to get to the first floor, starting from the ground level with 40 steps or runs all the way up to the first floor. Now in order to draw these stairs more properly, you could go to the final ramp in this level and uncheck End with Riser for it, then add one extra step to it. That'll be the nosing of the upper level. You can also see here that we've only got 39 steps, so we're going to expand this and make it 40. And that'll be it. Basically, you uncheck the End with Riser for the last one, and then you stretch it to add one more run. So now we've drawn 40 steps of stairs from the ground floor up to the first floor. Now let's try the same thing for the other staircase in this level. The overall or landing width for this one is 2.80, and so if we want to have a 20 centimeter wide stairwell on here, then what will be the run width? You see, from here to here is 280, which is structural to structural. Now if we subtract 5 centimeters from both sides, then it'll be 10 centimeters overall, and this will be 270. So now I'm going to divide it by the 20 centimeters we need for the stairwell, and we get 2.5. Alright, now if we divide that by 2, then we figure that the width of each run is going to be 1 meter and 25 centimeters. That's actually the exact same value that we had in the plan. Here it also says 280 from structural to structural, and basically if you keep a picture of this detail in your mind, you'll see that it's exactly the same as this one. Just notice the direction of the stairs. Those details are all for this plan. So the width of each run here was 125, which is just like what we had in the detail. Now I'm going to go over here and grab the stair tool, and the number of the runs is going to be the same as the previous one. This one also goes to the first level, so we're going to have its base from the ground floor, FFL, up to the FFL of the upper level, which is the first floor. There's going to be 40 runs, and we're going to set this one to 30, and this one's going to be 1 meter and 25. Alright, now we're going to draw starting from here, going up by 10 runs or steps. Then we're going to add 10 more on this side, then another 10-step flight on this side, and now we're going to draw the last one. Now because of the difference in the distance between the two levels, this changed to 39, which we're going to change to 40 again, and then we're going to stretch this flight to make it 40. Then we're going to uncheck the End with Riser for this one, then stretch it again, and we will have our 40 steps in total. Now let's readjust the landings. This one needs to go to here, and this one needs to be stretched to here. Finally, we're going to click finish, and we're going to go take a look at them in 3D. And here is how the stairs have turned out. This is the second staircase in this level, and now I'm going to go back to the plan to measure and double check the stairwell, and see that from here to here it's 20, and as for the width of each run, that is 1 meter and 25 centimeters. And thus we were able to draw all the flights of stairs that we needed for this level, but don't forget to always go back and forth between your main plans and double check the details, report the contradictions, and finally draw and model your stairs exactly how you're required.